This is 3 questions from 8.5. First of all, guys, in class on Friday, I said, here's WebAssign time. You guys can work on it. All weekend, I had 6 emails that I woke up to this morning. I don't know how to do the last 3, so you can't count that wrong on my score. I absolutely will count that wrong on your score. You guys cannot wait until the very last hour to pull up your homework and then be like, oh, wait, I don't know how to do something. When I tell you to look at it, kind of go through it, see what you have questions on, that you need to do that so then I can answer them. I'm not available to answer questions at midnight the night before something's due. All right, so just make sure you guys are being a little more diligent. I understand, seniors, you are so close to being done. Believe me, I get it. Spring break is just right around the corner. We're almost there. Just kind of keep plugging along. Couple things from your 8.5 that I want to make sure you guys understand. All right, it's the number of distinguishable permutations. Do you guys remember what that means? How do we do distinguishable permutations? It's the total number of letters on top, and then what do you divide out? The stuff that repeats. So how many total letters are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? All right, so it's 9 factorial over. Now we divide out the repeats. So what do you see repeating?
3.
C, how many times?
3 factorial.
So 3 factorial.
2 factorial for D.
2 for D, and then what? Another 3. All right, a lot of you on your quiz, you went like this. If you worked out something like that, you said 9 times 8 times 7 times 6, 5, 4, 3. You got to 3, and then you went like this. Oh, since there's a 3 and a 2 and a 3 on the bottom, you went, oh, this cancels all these. Is that the case? No. Just be careful with what you guys are doing. A lot of you made really silly mistakes on your quiz that kind of hurt. So here 3 cancels, here with 2, whatever. Here's the answer. But I want you guys to understand how to do. All right, 23 and 24, the same types of questions. Guys, we talked about permutation order matters. If someone's going for president, vice president, or parts in a school play where someone has a specific job. Or order doesn't matter. And how many different ways can a jury of 12 people be randomly selected from 35? If you're on a jury, you all have the same job, correct? So this is a combination. How many total people are in the jury pool that you could be picked? 35. And how many actually are on the jury? 12. Now, in a second, if you guys have your calculators, I'll show you the combination and permutation button in your calculators. But there is a formula. You guys need to know the formula, so I at least see you put on your paper this, and then you have this. And then you can do the rest in your calculator, but I need to see this part, so make sure you're aware of that. Now, this last one, yes, it's a word problem, but think about what this is. A law office interviews paralegals for 10 openings. Some people, what's a paralegal? Just say people. Doesn't matter. It's like a lawyer, right? There's 10 openings. There's 13 paralegals, so there's 13 paras that have 2 years experience, right? And there's 21 paras that have what? 1 year. They want to know how somebody can be chosen. They're all going to be doing the same thing. This is a combination. So there's 2 different combinations. They want 6 people with 2 years. So look at the 2-year stats. There's 13 paralegals that have 2 years experience, right? I want 6 of them. They want 4 that have 1 year. How many 1-year people are there? 21. And it says right here, something that will be very, 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 very important for you guys to understand is this word right here. What does the word and mean in math?
Times.
Yep. And means multiply. We're going to talk about that more today. And means to multiply, or means to do what? Or means to add. Yep, that's important. So this is what you would do to get this answer here. But remember, same job. We're all doing the same thing. We're on the same committee. That's a combination. You have different jobs, specific. Someone's vice president, someone's president, someone's treasurer. Someone's playing Lucy, someone's playing Snoopy, someone's playing Linus. Those are specific jobs. Does that make sense? All right, let's move along then. We're going to talk today about probability. You guys have heard this a million times. Probability, any happening whose result is uncertain is called an experiment. All right, probability results in the experiment are called outcomes. That's the set of all the possibilities. We'll talk about sample space. Those are the possibilities that could happen. And a subcollection of a sample space is called an event. All right, understand, guys, if you're talking about a six-sided die, what are your total possibilities on a six-sided die? Six. There's 6 different numbers on there. Probability basically comes down to what you want over total. All right, I'm going to refer to that a million times. Probability of an event happening is what you want over the total. Now let's talk about a scale. What's your scale of things happening?
Scale.
Yep. What's the lowest?
0.
0. What's the highest?
Infinity.
Nope. No.
Wait.
Like your scale of something to happen. I'm sure. Just think a little bit. What are the chances of rain?
100%.
100%. One whole, right? So think about this. 0 to 100%. This is not possible. Right? And over here is absolutely certain that it's going to happen. So your probability is going to fall within that scale, either from 0 to it never ever happening to 100% certain. Now you can have probability as a percentage. You could also have it as a decimal. It can go from 0 to the whole number 1, right? Have a decimal in between. And it could also be a fraction. So depending upon what the question is asking or how it's asked, if it starts off with decimals, then leave it in decimals. If it starts out as a fraction, leave it as a fraction. But you can get probability of something and turn it into a whole number, a fraction, a decimal, or a percent. So we'll talk about that in a minute. All right, finding sample space. Just what are your outcomes possibly is what we're going to talk about for a second here. What are the 2 outcomes? What's the sample space in A? If one coin is tossed, what are the 2 possibilities? Heads or tails. Agreed? All right, what about with B? You can get 2 heads, 1 heads and tails. Tails, or tails, heads, all right? So what happens to your sample space when you introduce new things into your experiment? It doesn't necessarily double. In this case, it did, but it increases, correct. So if I have 3 coins, well, think about our possibility. I have a head and a tails, right? All right, well, with that heads, could I get 2 heads? Could I get a heads and then a tails and a head? Could I also get a heads and then a heads and a tails? Could I also get a head and then 2 tails? All right, so what's happening, guys, as the more you introduce, what happens to your outcomes? The more you, okay, they get bigger, right? So understand that. If they give you a sample space and say, what's the probability of this happening? Think about what probability is. Probability is what you want over what? Total. Always think of it that way, and it'll make this a lot easier, I promise. All right, an event, E, is equally likely outcomes in the sample space. But here is probability. Again, it's what you want over total. We're going to talk about a whole bunch of different situations here. This is what I just talked to you guys above about the events happening, the likelihood of it happening. The closer you are to 0, the least likely it is for something to happen. The closer you are to 1 is the most certain. Does that make sense?
Yes.
Okay, so look, this is on a scale of whole numbers here, 0 to 1. You can also make it a decimal. You could also as a percentage, and you could have it as a fraction. So let's just talk about some of these problems. All right, let's look at A. It says 2 coins are tossed. What's the probability that both land heads up? Two coins are tossed. Well, what's the probability that the first one is a heads? 1 out of 2, right? So you flip a coin, and think about this, guys. You want them both to be heads up. So is it you flip a coin and you flip another coin? Or you flip a coin or you flip a coin? And. So then what do I do with these 2? Okay, so what is the probability that you flip 2 coins and they land heads up? There you go. These cards, you're going to talk about cards a lot. A card is drawn at random from a standard deck. Uh-oh, we're supposed to know how many cards are in a standard deck. 52, okay? What's the probability that it's an ace? So think about this. When I say want over total, this might help some of you guys to visualize this. What do you want to happen? An ace over the total. How many aces are in a deck? 4 out of how many total? 52. If I simplify that, what does it become? 1 out of 13? Okay. Now, if they said answer as a simplified fraction, there you go. If they said as a decimal, then 1 out of 13. They probably won't do that because that's not a pretty decimal. Anytime you talk about probability, put what you want, put it in words, what you want over the total, and it'll make it easier. All right, 12-sided dice is shown in the figure. We'll come back to this one. We'll wait till more people are here so we can go through that one. Random selection. Okay, we got a map. It says the numbers of colleges and universities in various regions of the United States in 2008. Wow, this is a little dated. One institution is selected at random. What is the probability that the institution is one of the 3 southern regions? So let's think about this. Probability. What do we want? 3 southern regions, right? Agreed? Over total. How would I go about figuring this out?
Add up all the southern regions.
Perfect. Add up the southern regions. How do I know which ones are the southern regions? They will have a south in it. So 754. You guys agree? And then what? 286? 406? Okay. So that's my numerator. And then my denominator is everything. Not just what's left over, it's everything. So I'm going to start here at South Atlantic and just go around. So 754, 630, 265, 630, 265, 668, 453. Check me, please. 304, 581. 581, 406, and 286. All right, so think about it. It's what we want over the total. So I want one of the southern regions to be chosen and then add to the total. So take your calculators out, guys, and be careful. Add all these up. For the numerator, I got 1446. Good, let's do the bottom. Check, Jackie. All right, so on the bottom, I got 4347. All right, so 1446 over 4347. Does that fraction simplify? 7 and 4 is 11, 12, 13, 14, 15, 16, 17, 18, 10, 11, 12, 13, 14, 15. It should divide by 3. What's 446 divided by 1446 divided by 3? 482. All right, and then what's 4, 3? 1, 4, 3, 4, 7. Say it again. 1, 4, 4, 9. Okay, so say they wanted it as a simplified fraction. What about if they wanted this as a decimal? So you would say 482 divided by 1449. All right, so you'd get approximately 33. So 0.33. What if they said they wanted it as a percent? It's about 33%. So all 3 answers you guys can convert back and forth to, just depending upon how they ask for the answer. A fraction to a decimal to a percent. We need to be able to do all of those calculations. Everybody with me? Okay. All right, now we're going to talk about 2 different things. Something called mutually exclusive and something called overlapping. All right, mutually exclusive. This is what this means right here. But I'm going to explain it to you in words. Mutually exclusive events have nothing to do with one another. One event does not affect the other one. An overlapping event has common outcomes that overlap. All right, you see this a lot, guys. A lot with decks of card problems. What I mean by overlapping versus mutually exclusive. If I say, what's the probability of getting a 2 or a jack? Are there any cards in the deck that are a 2 and a jack at the same time? No, those are mutually exclusive events. An overlapping event would be, what's the probability of me getting a black card or a 6? Are there cards in the deck that are 6 and also the color black? So those are the difference between mutually exclusive and overlapping. Sometimes it's helpful. All right, this is in modules, your standard deck of cards. I put it in there, so you guys can, if you are still having trouble with this after we do a couple, just kind of put this next to all your deck of card problems, and it'll make things a little easier for you. But it says, what is the probability that you select at random from a deck of 52? Probability that the card is either a heart or a face card. So this is how I would do this problem. A heart or a face card. So I would write down exactly what I want. All right, I want the probability of a heart or a face card. Do you guys understand what I just did there? Okay, I wrote down remember, it's what you want over the total. So how many hearts are in the deck?
13.
There's 13, okay? 13 out of how many? 52. What did I tell you the word or means? Or means to add, all right? How many face cards are there?
12.
There's 12 out of how many? 52. Now, if you're kind of like, oh, I still don't know if this is overlapping or mutually exclusive, think about this, and I'll show you why this matters. Here's all the hearts. Do you guys see in yellow the hearts? All right, now here's all the face cards. Do you see any place that there is an overlap?
Yeah.
Yes. Anytime you have an event that is overlapping, you have to subtract that part of the event, because if you don't, then you're counting it twice. So you would work this out and you'd say, okay, well, the probability of a heart is 13 out of 52. The probability of a face is 12 out of 52. But what do I have to subtract? 3 out of 52. Why do I have to subtract those 3? Because they're overlapping. They're hearts and face cards. So you'd be counting them twice. If it's mutually exclusive, it's what's the probability of getting a black card, an ace or a queen. Those have nothing to do with each other. There's aces and there's queens, but there's not ace queens on anything. So anything that's overlapping, you have to subtract that event. So now if we go through here, what is 13 plus 12? 13 plus 12, 25. Minus 3 is? So 22 out of 52. Simplify that. We always simplify. What's 22 out of 52? As a fraction, what would that be? 11 over 26? Okay. If I wanted a decimal, I would divide. If I wanted a percent, I would divide, then move the decimal point. Does that make sense? Okay. A lot of times, guys, the more that you can write down and show yourself pictures, it makes it easier. You guys will have no problems with questions like this. You're given a table, right? What's probability again? What you want over what? Total. Okay, just remember that always. Human Resource Department, blah, 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 blah. It says an employee, what's the chances that our employee is chosen with the following conditions? 4 or fewer years service. Let's think about A. I want 4 or less years service over the total, correct? How would I figure out who has 4 or less? 0 through 4. How many is that? 157. How in the world, guys, could I figure out the total? You'd have to add them all up. All right, so do that real quick. Okay, I got a total of 529. All right, perfect. So out of these employees, out of 529 employees, 157 of them have 0 to 4 years experience. Does that make sense?
Yes.
If I was going to change that into a fraction, a decimal, I would divide, yeah? All right, let's look at B. B says, okay, fine, I want to know 9 or fewer, so 9 or less over the total. Does the total number of people change? No, it's still 529 people. How would I figure out who has 9 years or less? You add 157, good, and what? 89. And you get 246. Okay. Does that simplify? 10 to 9, 5, 13, 14, 15. It should, yeah, by 3, right? Do you guys know what I'm doing? I just added up the digits. 246 divided by 3 gives me 82. And then 529 divided by 3. Nope. So it doesn't. Okay. So 246 over 529. All right, so if they give us a chart, it's real easy. Super easy. All right, independent versus dependent. Guys, what does the word and mean? And means to multiply. What does the word or mean to do? Add. That's going to be super duper important information. All right, you're going to talk about dice, rolling dice. You're going to talk about pulling marbles out of a bag, all that good stuff. All right, random number generator on a computer selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? So first of all, what do we want? 5 or what? 5 or less out of the total. So what's the probability that one of them is 5 or less? How many numbers do we have? If you don't know, write them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many numbers do I have total to choose from? 20. What's another way I could have figured that out without writing them all out? What was the formula that we used on our quiz?
Minus 1 plus 1.
20 minus 1 plus 1. Yep. Because if you have more, if say it started at 4, and then you'd have to be like, oh, I don't know how many. Just take big minus little. Okay, so there's 20 total, yeah? How many of those 20 are 5 or less? 1, 2, 3, 4. 5 of them, right? Do you guys agree? So what's the probability of one of them being less than that? 1 over 4, right? Now think about this. I want to have 3 of them less. Here's where and or is really big. If you're generating a 3-number code, do you generate a number or another number or another number? Or is it a number and another number and another number? And. So what am I doing with 1/4 3 times? Multiplying it. So this is really 1 out of 64. You're not adding them where you'd get 3/4. It's 1 out of 64. Very important, and we differentiate between and or. Very, very important. All right, last bit. Talking about marbles. You guys will see this a lot. And again, this is all about wording. Think about this. With replacement, I reminded you guys, what does that mean if I replace? What do I do with the marble? I put it back. If it's without replacement, I don't put it back. So there's 8 marbles in a bag. 4 red, 2 green, 1 yellow, 1 black. What is the probability that I pull out 1 red and 1 yellow? But what is really important here? What does it tell me? Without replacement. So think about probability is what you want over the total. So I want red over the total. And I want yellow over the total, correct? Now think about this, guys. This word right here says and. What am I doing to those 2 numbers? Multiplying. All right, so let's think about this. How many in this bag of marbles are red? 4 out of how many total?
8.
Perfect. And what did I do with this marble that I took out? Did I put it back in the bag? No, I threw it at Celine, and she caught it. How many marbles are left in the bag now since I just threw one at Celine? 7. Good. And of those, how many are yellow? Make sense? Multiply. 4 times 1 is 4. 8 times 7 is? What can I do with 4 over 56? 1 over 14. Good. Now, how can we change this problem? I could have done the exact same thing, but instead of the word and, I put or. What would that mean to do? Add. Okay? This is where you guys just got to pay attention to the wording. In this second question, I want the probability of black or a red Or means to do what? Add. So how many black marbles are in the bag? 1 out of 8, correct? Now, what did I do with that marble? I threw it at who? Celine. I'm picking on Celine today. So how many marbles are left in the bag if I took one out? 7. Good. And how many of those are red? 4. How does this problem change? I'm adding. So now if I'm adding, what do I need to get? Oh, yeah. Common denominator. What's my common denominator between 8 and 7? 56. Okay, so if I multiply 8 times 7, then I multiply the top here, so I get 7. 7 times 8, so multiply the top, 8, so 32. What's 32 plus 7? 39 out of? All right, changes a big time. 9, 10, and 12. Nope, okay. All right, let's look at the next one, and then we are finito. You guys doing great, thank you. 8 marbles are in a bag, 4 green, 4, everything looks the same. What's different? With replacement. What does that mean? I put it back. What's going to happen to the denominator? It's going to stay the same. Do you guys see that subtle difference of with and without replacement? Or the subtle difference of and versus or? Makes a huge difference. So here I want the probability of red and green. So multiply and green. How many red are there? Out of 8. I looked at the marble. I saw it was what I wanted. I did what with it? I put it back in the bag. So now how many green are there? 2 out of how many still? 8. We multiply across. We get 8 out of what? 64. Does that simplify for us? What? There you go. Good. Very good. And our last one. Excuse me. Probability of green over total, or means to add red over our total. So how many green? Out of plus, how many red? Out of. Do I have a common denominator? Yes, so all I have to do is just add my numerators. 2 plus 4 is 6 out of 8, which gives me what? 3/4. Good. Very good, guys. And that, ladies and gentlemen, is the end of chapter 8. So I will give your quizzes back on Wednesday. We'll go over them. I may not let you take them home if I still have people that need to make up, but we'll at least go over it. You guys can look at it. And then please open up your web assign tonight. Come to class on Wednesday and say, hey, I have questions about this. I'll even extend the due date. I'll push the due date back to Thursday. So you guys have time in class if you want to ask questions.